So here's the problem with file extensions. We've got this text file that is SVG. And we have these other things like PNGs. But the question is, what is it associated with, and does the file even have the right contents for the extension? Because the extension is really just, all it is 3 letters or 4 letters that says, well, this might be what's in this file. If I do an ls and list the stuff in here, you'll notice that I have .png and .jpeg. But if I go in and look at what these are, well, the PNG, the JPEG looks like it says, no, inside I'm really a PNG. And the PNG says it's a PNG. And the structured vector graphic is text. So there's nothing guaranteeing that file extensions aren't lying to you as well. In fact, this is so common that you'll notice that the browser actually, although it said it was a PNG, it opened it up and treated it as a JPEG. Because if you interpret a PNG as a JPEG, you will get a bizarre result. But if you actually poke into it and look at it and say, no, this is really this kind of file over here, you'll get the result you're expecting. So what is the kind of things that I actually use in relationship to editing images? I put together a list for you, and then let's ask a question about it. And we've got Chrome and Firefox and Opera and things like that, browsers. I've got image editors like Inkscape and Adobe Illustrator. Obviously, my text editors for SVG, like Vim and MacVim. I've also got XML Explorer on there, which is a specific XML editor. There's another text editor that I use some of the time called Atom, another editor. And then we've got integrated development environments, and it depends on which kind of programming language I'm working in, but Microsoft Visual Studio, Xcode if I'm working on an Apple desktop or a iOS mobile tool, and PyCharm if I'm working in Python. There are some unusual graphics tools that I use, like Hugin, which is a tool for building big images. And there's things like ScreenFlow, which is what I'm processing right now, that if I want to put an image inside ScreenFlow, it's probably going to be a structured vector graphics tool. There's TextEdit, which is the text editor built into a Macintosh. I rarely use TextEdit. This is like Notepad on Windows, but I almost never use it. The only thing I use it for is for printing. If I want to print a text file, that's how I do it. The rest of the time, I never use it. So these are all the different possible things that you could associate with .svg. Which one's the right one? In fact, even if I do edit with, you'll see that I have lots of things in there that don't show up. And then I've got some things in there that are wrong, like GIMP, which is an image editor, does a horrible job of editing SVG images because it's a pixel image editor, not a vector image editor. So, this is a possible set, and depending on day, depending on what I'm working on, different groups of these could be associated with SVG. As a developer, you're going to use more than one tool. You're not one of these people that is a GUI cripple that has learned how to do PowerPoint, and if you want to have a table of numbers in a computation, by golly, you're going to do it in PowerPoint because that's what you know PowerPoint. And if you want to edit an image, you're going to do it in PowerPoint because that's what you know is PowerPoint. And PowerPoint solves all the world's problems. You're not going to use Excel for your tables and calculations. So, that may work for somebody like that. But as a developer, as somebody that builds software, it doesn't work that way. You use lots of different tools all the time, and file extensions are more an annoyance than they are a useful tool. Let's move on to directory listings. You will have noticed at some point that I have done multiple different directory listings. Okay, I've done ls. We've got a bunch of directories out here. Now with some files that are truly annoying, like my something stuff, with some number of spaces in it, and a file name with a space in it, and files with special characters. But there are a bunch of different things we can do with ls. ls gives you a list of the files in your current directory. It can give you a list of files in your home directory, or /bin, which is my bin directory. So lots of different files. We can get a long listing, as in it lists more information about the files. And in all these cases so far, it's sorting by file name. So the different columns in a long listing, we've got some stuff out here. We've got the owner of the file. We have the group that the person happens to be in. We have the size of the file in bytes. We have the date that it was modified. And over here we have the file name, whatever that is for that file. So we can get a bunch of different stuff out of this. We can also change what appears on this long listing. If I do ls-lo, it took out the group. So that turns off the group. If I want it to be sorted in reverse order, as in right now it's sorted lexicographically in increasing order. If I want to do ls-lor, R reverses the order, and now I've changed the order. But what I really want to do is I want to sort it based on time. So ls-ltro will take out the group, it will reverse the order, and it will sort it based on t time. And I find out that, yes, the last file that I modified was down at the bottom of the list, and that's this one right here. Now, where does this become useful is if, say I download a file to my downloads directory, and what I really want, and I've got lots of stuff in my downloads directory, what I really want is the last file in the list to be at the bottom of the list so I can see it and it doesn't scroll off the screen. So lots and lots of times I'm going to go out and list a directory minus LTRO so that I can see what I just changed at the bottom and it's visible. Now, sometimes you want stuff, you'll notice that ls is in multiple columns, you want it to be in one column. So you can do ls-1 and you can list it out in a single column. We can combine ls with other things. We can do ls piped to grep, and we're going to get to what the different pipes are. But let's say that I look for every pattern that has 7 in it, because I've got a directory that has lots of files, and I'm really only interested in the ones that start or have the digit 7 in them for some reason. So we can combine it with other things. Another thing that ls has is you can list all the files. You'll notice that now suddenly in my list there is dot and there is dot dot. Remember, dot is your current directory and dot dot is your parent directory. In fact, if I do ls-la, I get a long list and all the files. It's still sorted alphabetically, and we've got this mystery file up here. I don't remember if I put a tab or a space in it now, but it's up at the top. Now this first column over here, I think I've talked about this before in class when we were talking about number conversions, but let's get really specific about what's in that column. Unix and Linux have 3 different groups of permissions. There's another set of permissions called access control lists. That's a whole different matter. Windows works on access control lists, but if you're using the Linux subsystem on Windows or you're using Bash, it's going to emulate this. And those 3 groups of permissions are read, write, and execute. Right here you'll see read and write. That little script we built, I set the execute permission with chmod, ch the permissions, and you'll notice it has read, write, and execute. If you want to be able to run something at the command line, it has to have execute. And this is for files. You'll notice the very first character in all the files is a minus sign. That means it's a file as opposed to some other things like a D, a directory. And there are some other special files. If I do ls-l/dev, you'll see that there are C's and P's and S's. But here, let's just look at what we have for files in our normal directory. So if it's a minus sign, it's a file. If it's a D, it's a directory. Now, the permissions are different for directories and how it gets handled. But on a file, the first 3 of these are the permissions for you, the owner. So if I change the permissions on b.text, I can say take away the write permission on b.text. You'll notice that now it just says read nothing, nothing, read nothing, nothing, read nothing, nothing. And if I go to edit b.text, okay, oh, it edits. But down here at the bottom in VI, it actually tells you that it's read-only. If I try to, oops, I'm inserting to a read-only file, and I can't write to it because it's read-only. Okay? So I can make files that you can't update. You can't write to them anymore. Now, I could still remove that file and get rid of it, and we'll explain why that is the case. But now I can't update it. So you can create read-only files. In fact, you can create files you can't see at all. And I have just made a file that is all minuses. I can't read it and I can't write it. And you go, why would you ever want to have a file like that? But there are some reasons. You're trying to create a file that is a temporary file name inside a program, and you haven't set the permissions on it so you can actually access it yet, but you want to make certain that you get the file name and preserve that file name from other programs. They come in like this, as 0 permissions. You can't read it, you can't write it, until you actually change the permissions and make it available. So there are utilities to these odd permission sets. So the 3 groups are you, the owner, which is like read, write, minus. It's not executable, but you can read it and write it. The group that you belong to at this moment in time, which is read, and they can't write it. So other people in the group can't write it, but they can read it. And everyone else that isn't in your group is the third set of 3 bits there. Now, 3 on-off bits makes 1 octal digit, so most of these things are specifiable in octal numbers, and that's the way that chmod works. I can do chmod 0 to say that it's octal, 644, and I can get back my read, write, and read back on b.text. Now, the octal numbers that are really common is 644, and if I want to make something a directory that is accessible, it'll be 755. Now let's talk about directories and why that is the case. Directories have read and write. Read means that you can actually read the directory and get a listing. Write means that you can update the stuff like removing files. But the execute permission on directories has a special meaning. It means that you can search the directory. And lots of things want to search. We talked about our path. When the shell goes to search directories for executables, it's using that path. So it has a different meaning for directories, the execute bit. Now, if I create a directory that is not writable, then people may be able to read it, but they can't delete the files because they can't write to the directory and they can't create any new files. So there's some utility to being able to build these things that are non-writable sometimes. For instance, if I have a group that I'm using to serve web pages and it's serving web pages out of a directory, I may want only the owner to be able to update the files in that directory, but I may want that group to be able to read the files. And that gives me a certain level of security on how it works.